Hey everybody. Today I'm thinking about missing data in the bikeshare dataset. This is a question that came up in a recent vid I recorded where I was using the bikeshare dataset as an example of Poisson regression in R. And towards the end of that video I noticed that the bikeshare dataset has 8,645 rows, even though each row is supposed to represent an hour during the year 2011. And in a 365-day year, there's 8,760 hours. So it appears there's 115 missing rows in this data set. So today, I would like to deal with that issue. I'd like to try and complete this data set using imputation of the variables I'm interested in, hopefully in some pretty sensible ways. The bikeshare data set comes from the ISLR2 package that I've already loaded up. That's a package of data sets supporting the excellent book Introduction to Statistical Learning with Applications in R, which I highly recommend. I've also loaded up tidyverse, of course. I'm going to use a bunch of verbs from dplyr and tidier. And I've also loaded up broom. And towards the end of this video, I'm going to use one or two broom functions to compare the model I got in that Poisson regression video with an equivalent model built using a data set with that's a little bit more complete. All right. So, reminder that the bike sharing data set is taken from the DC bike sharing system back in 2011. We've got a number of different variables, 15 of them in all. And you can see that there's some about the time of year, the sort of day that we might be talking about, the hour of the day. And then we have some environmental things like temperature and wind speed. And the response variable that we'll be interested in any model that we make is going to be the number of bikes actually rented in that hour. Now, I am approaching this video with the assumption that the rows that are missing in this data set really should all be zeros for the bikers variable. And the reason is that if I look at the bikeshare data set, and let me view it now. For bikers, there are a number of very small numbers here, 1, 2, 3, but there are not actually any zeros. And you can see that kind of as you scan through it, but you can see it more efficiently with a command like this. So sum bikeshare $bikers equals 0 is going to go through that bikers variable and ask, is each value equal to 0? So first, second, third element in that vector, is it equal to 0? That's going to give me a lot of true falses. The trues will code as 1s, the falses will code as 0s. So the sum is literally just going to be the number of zeros in that column. And so I'll execute that, and you can see that I get 0. So I think it's reasonable to believe that the missing rows in this data set are just hours when no bikes were rented. They didn't bother to include data in that situation. And there's at least one other reason for that I think that's a reasonable assumption that I'll point out a little bit later in this vid. Now, if this were a higher stakes analysis and not just some YouTube video, I would want to send an email or send a text to somebody actually involved in building this data set to try and confirm this. I am definitely making an assumption about my data here. All right, so my plan for the next few minutes is going to be to add some rows to the bikeshare data. Wherever I find an hour that's missing, I want to stick a row in with the appropriate day and hour. And then, as appropriate, I'm going to want to impute some missing values. I'm going to want to put zeros for the number of bikes rented in that hour. And then I'm going to want to try and put in something reasonable for temp, weather sit, and working day. And I'm picking those three variables because those are the variables of interest in my model. And if we're able to impute those effectively and intelligently, I think you'll be able to follow those same ideas to impute other variables as needed. Finally, the last thing I'm going to want to do is to compare the Poisson model that I built in that last video to an equivalent model built with a more complete data set, the one that I'm going to build in these first couple of steps. Okay. So let's get to it. Let's take this bikeshare data set and make sure that we have every combination of day and hour that we should. So the first thing I'm going to want to do is to just get a data set with all the appropriate combinations of day and hour, and then I'll end up joining the bikeshare data set to that in just a second. So the command I'm going to use is expand_grid, and let me pull up the help file on that. Expand_grid, that's a tidier verb from the tidyverse family of packages that is more or less equivalent to the base R function expand.grid. And for the purposes of this video, either one would work. The primary difference there is that expand_grid sorts by the first variable that I'm going to pass it rather than the later variables, which for me feels more natural, that the first variable is in the chunks rather than the second. By the way, it also is going to return a tibble, not a data frame, so that can be nicer for certain purposes. Again, not a huge difference between expand_grid and expand.grid. So I want two variables. I want day, which, by the way, is numeric, going from 1 to 365. And then I want hour, going from 0 to 23. Now, notice that hour here in my original bikeshare data set is a factor variable. It's categorical. Right now, hour, as I have it here, is going to be double. It's going to be numeric. And that's going to create a bit of a problem for us in a minute. I'm not going to change that right away. Let's just print this out a little bit. All right, so the fact that I used the underscore here rather than the dot in expand grid means that this doesn't overwhelm my, my console when I print it out. And you can see the first few rows of my data set. And I've got day and I've got hour. There's 8,760 rows. I have 24 rows for each day. And then for hour, it goes from 0 to 23. So this is what I want. What I'd like to do now is to take the bikeshare data set and add all of the other columns from it to this thing. And I'm going to do that with a left join. Now, the fact that hour here is a double and in my bikeshare data set it's factor is going to create a problem, but let's just actually do it and illustrate that before we go back and fix it preemptively. A lot of times when you're working in R, you'll do a thing, you'll get a sensible error message, you'll realize, oh yeah, there's this problem, then you go back and fix it. It feels a little disingenuous to me to always be doing things exactly right the first time when I'm recording a video, when in fact my actual process is much more iterative than that. And yours will be, certainly as well. All right, so left join. Left join needs at least two arguments, two data sets, the thing that you're joining to and then the thing that you're joining. So I have a pipe here, so the thing I'm joining to is going to be this expand grid thing. And the thing I want to join is bikeshare. It should be left_join, sorry. There we go. And again, I should get an error when I execute this. And there it is. Can't join because we have incompatible types. In the second data set, we have a factor, and in the first data set, we have an integer for hour. So what I'm going to want to do is, in my expand grid, instead of having that be quantitative, I want it to be factor, so let's put in as.factor of that vector from 0 to 23. And this should now work. There we go. Right now it's just printed out. Let's not do that anymore. How about bikes new? And I should re-indent that. I could use the magic wand for that if I were being a bit more sensible. Okay, notice the message, joining by day, hour. By default, left join is going to look at the two data sets it's being passed and identify all the columns that are in common with both, looking at their names. In this case, day and hour exists both in that expand grid and in my original bikeshare data set. So it's joining using both of those. Now, here I can see that's what I want, but honestly, when I'm doing a left join, I almost always specify the by command directly because I don't typically know off the top of my head what all the variables in both of my data sets are, and there's just a number of ways that this could give me some unexpected behaviors if it ends up joining on some columns that I don't necessarily notice or don't necessarily want. So I think I'll go ahead and put that in here. I think I'll even just copy and paste it. I know it's kind of silly, but let's do it that way. And let's take a look at bikes new. Make sure it's what we want. Okay, so 8,760 entries with 15 total columns. That's great news. That's exactly the number of rows and columns that we would want. Now, if we sort of seek down here a little bit, we get a little more good news. Take a look at this row with missing values. This is one of the rows that was inserted on, January 2nd at 5 a.m. In the original bikeshare data set, day 2, hour 5 does not exist. You can see it's missing here. And so in our bikes new, we now have day 2, hour 5, and the rest of the row is NAs. And those NAs were all produced when the left join command was executed because there was no data provided by the data set we were joining, bikeshare. All right, that's great news. So we've got the basic data set we want to work with. Now what we'd like to do is to impute some missing values. In particular, to start, wherever I have a missing value for bikers, I want to put in a 0. This is my whole assumption of this vid. My whole line of thinking coming in is that wherever I have a missing value here, I should put in a 0. And again, this is going to be my response variable. So if I'm building a model, the idea here is that this should give us a more honest picture of the number of bikes rented. Previously, if we don't have zeros in here, we would have had probably slightly inflated estimates. Okay, so I'm going to want to do a mutate. So let's see here. I think I'm going to save this as bikes imputed. I don't like having lots and lots of more or less equivalent data sets floating around, but I think I want to hold on to bikes new in case I mess something up here. I don't want to just overwrite it every time. So let's take bikes new, and we'll pipe it in to a mutate command. And again, the first column I want to mutate is bikes. Right? Bikers. Sorry. There we go. And all I want to do is to replace the NAs. So I'm going to use the replace NA command. Let's pull up the help file on that one. So this is another one from the tidyr package, another tidyverse package. Replace NAs with specified values. And we can either do it in a full data set or just a column, just like a vector. I'm doing the latter right now. And so all we really need to specify is what we want to replace those missing values with. So I want to replace in the bikers column, I want to replace my missing values with 0. And let's just take a look at that. Let's make sure that this is working sort of at every step. Make sure I'm not being dumb, not being too dumb. So what I want to find here is a row that has all those NAs, like this one. This will be that 5 a.m. on February 5th. And notice that I have 0 for bikers. And let's just find 1 or 2 more. There we go. So down here we have that as well. All right, so I'm very happy with that. The next thing that I would like to do is to deal with this temp variable. And my idea is that temp can reasonably be imputed by adjacent values. And there's any number of ways I could do this. I think I want to be a little bit careful with this, although we could certainly be faster if we were willing to give up a little bit of care. Conversely, the procedure I'm going to use could be improved upon, and I'll say something about that. What I'm thinking is that in a case like this, at 5 a.m. on January 5th, where I have 0.46 and 0.42 before and after, the natural value to put in for that missing temp is 0.44, right in the middle, doing a linear interpolation there. So I'm thinking if I just have one missing value, I could take the value before and the value after and average it. By the way, the temp variable here is on a 0 to 1 scale. What they've done is they've taken the minimum temperature for the year, the maximum temperature for the year, and then scaled that all so that temp here goes from 0 to 1. Presumably the people that made this data set were thinking about like a principal component analysis or something where the machine learning model they're using is really more sensitive to the scale of the variables, and so they're trying to put everything on a common scale. Doesn't end up mattering for us, but that's the explanation, or the likely explanation for that. Okay, so the first thing I'm going to do is to mutate temp to take the value before, the value after, and just take the average. All right, so there's lots of ways I could do that. Let me put a little extra space here at the bottom of my screen so that this comes up a little bit higher. So temp equals, I want to do an if-else. Because if, use .na, if temp is not an NA, then I just want to keep it as is. So if temp is an NA, what do I want to do? Well, then I want to replace it with the average. So I want to take the lead of temp and the lag of temp. So the lead and the lag, the one that comes before and after. And I want to divide that by 2. Okay. I guess I could have just used the mean function here if I'd been a little bit more on the ball, but what do you want for nothing? So if temp is an NA, do that. And if not, then just give me back temp. And close up that parenthesis. I think I've got it now. Let's take a look how that came out. Let's view bikes imputed. And once again, we'll go down to 5 a.m. on January 2nd here. And let's see what happened to temp. All right, so we got what we want. 0.22 for the hour after, 0.46 for the hour before, and 0.44 right in there. Now, that didn't do anything when we had 2 missing values in a row, because, for instance, for this first one, it would be trying to fill in the average of the hour before and the hour after. The average, whenever you put an NA in there, is going to be an NA back. Now, if I wanted to, I could continue with some linear interpolation here. So, for instance, I could say to get from 0.20 to 0.16, I should drop down by 1/3 of the difference every single time for each of these 2 NAs. So, take that as a challenge, exercise left for the reader. I think what I'm going to do in this case is be a bit more lazy. I'm going to, in a situation like this, if I have an NA and I don't have values on both sides, I'll either take the value before if that's there, or the value after if that value's there. And the order in which I do that really doesn't matter because I've already taken care of this case where I have both. All right, so I'm mutating temp again, and I want to do another if-else. And again, I'm thinking about, is temp an NA? Right? And if it is an NA, then I'll just do lead of temp. And if not, I'll do temp. Okay. I'm being a little verbose here, but I can get away with it just because it's all copy and paste. And then I'll do the same thing with lag. Okay. So the idea is this first one should resolve the NAs where temp exists before and after. Then if that's not the case, this should resolve the case where there is, not an NA before, and this will resolve the case where there's not an NA after. And I'm getting okay. Does this work? Let's see. I was seeing the X for the number of parentheses. There we go. All right, let's take a look at bikes imputed now. Let's see how we're doing. All right, so where were those 2 missing values in a row down here? There they go. And now for temp, you see we got 0.20 and 0.16. So that's great. Now, this is being a little bit conservative here. I definitely am still going to have some NAs in here. And you can see that as we get further down, there's going to be some places where there's strings of NAs that I haven't touched. Maybe I shouldn't just scan all the way through. Right now, my imputation is assuming that I have a value either immediately before or immediately after. And if I don't, it's still going to leave temp as an NA. Let's actually see that. Let's do sum of bikes imputed $temp, and I actually want an is.na in there. So the fact that I still have 45 missing values here is indicating that my imputation was not complete. And the philosophy I'm using is just that if I don't know what happened an hour before or an hour after, maybe I shouldn't be making guesses about what happened that hour. I don't want to reach out more than 1 hour in each direction. That's a data choice. There's certainly other choices that you could make. Okay, so we've dealt with temp now. The next thing I want to look at is weather sit. And what I'd like to do is to just take the weather sit on maybe the hour before or the hour after, do something very similar. Okay, great. And here it does matter what order I put, because I can't take an average of my weather sit. If the one before and that one after aren't the same, I have to pick. So I think I'll pick after. And let's see here. I'm going to start with another if-else, but we're going to get an unexpected behavior here that I want to illustrate. So weather sit should be dealing if, again, if weather sit is an NA, right? If it's an NA, then let's start by taking the one before. Okay. And if not, then we'll take weather sit. Okay. And then we can do a similar thing. I think I'm missing a comma there. There we go. Trying to get the alignment right. All right, so let's see here. If weather sit is an NA, then give me the one that came before. If not, give me the value that you have. Then, if weather sit is still an NA, look at the one that comes after. And if not, just give me weather sit back. Now, something unexpected happens here, I think. And let's view bikes imputed now. And we're looking at weather sit. Now, previously, for instance, in bikes new, weather sit was things like cloudy, misty, light rain, snow, etc. It's descriptive. But now for bikes imputed, weather sit is numbers, 1, 2, 3. So what's going on here? Well, this is actually a behavior of if-else that I had forgotten about, so let me show it to you. I'm pulling up the help file for if-else here. Always a nice thing to do occasionally, especially when code doesn't behave the way you want. And the thing that I want to point out is here. If-else strips attributes. So a factor variable is 1s, 2s, 3s, and 4s underneath the hood, just with labels on top. And so the if-else command is actually stripping away those labels and just giving us back the numbers of the categories. So I don't love that. I don't want that. So I'm actually going to go back and instead of using if-else, I'm going to use another function that I think is even nicer here, and that's case when. And again, there's lots of different ways that you can do the same task. And this is your dplyr version of if-else. It is a vectorized version. And so what I'm going to do is I'm going to take weather sit and I'm going to do case when. And I'm going to want a few cases. First of all, if I don't have an NA for weather sit, if it's not an NA for weather sit, then I just want weather sit. Okay. And I'm checking my numbers of parentheses here. All right. Otherwise, so true, so this is like a default value, then I'm going to put lag, put the one that came before of weather sit. Okay. I could do all of this in one case when, but I just find it easier to copy and paste in this case. So I'll do another case when now. And this time, if I still have an NA, where's my cursor? There we go. Then I'll do the lead. I think that should give me what I want. Oh, I got an error. Probably miscounted parentheses. Yep, there we go. All right, let's take a look at Vikes imputed again. And see how we did with WeatherSit. So we'll go down to our favorite hour, January 2nd at 5 a.m. And we can see it got the value before, cloudy, misty, not the value after, light rain, snow. Again, that's a data decision. It won't end up making a huge difference in our model, but it will make a difference. If we go further down, where we had the two missing values, both were inserted. This first clear came from the one above it, and the second clear came from the one below it. All right, great. So hopefully we've got sensible values for both temp and WeatherSit. The next one I want to look at is working day. And it might be worth pausing the video for a second and thinking about how you might want to impute working day. I actually have done this 2 or 3 different ways as I was preparing this vid. Initially, I did something pretty similar to what I did up here. I did a lag, and then I thought, well, that's great as long as it's not lagging me to the previous day, if it's at midnight. So I did a case when, that kind of thing. It worked, got a little more complicated than I would like. I want to actually do it a slightly different way. Here, I can actually be a little bit more aggressive with imputing working day. Because if I have even 1, 0, or 1 for a day, I can take that to be complete information about whether the day is a working day or not, even if I only have one observation for the entire day. It doesn't change, a day doesn't change from being a holiday or not as the hours go on. So what I'm going to do is to mutate this groupwise. So what I'm going to do is I'm going to take the mean of working day. Okay? And remember, working day here, if we just to remind you, working day is coded as numerical. So let's glimpse bikeshare, I guess. Doesn't really matter. Working day is 0s and 1s. So I can get away with this mean right away. And I'm going to leave out the NAs. Na.rm equals true. Okay. So as it stands now, this is just going to take the average value for working day throughout the set. That's not really what I want. I would like it to do it by day. So I'm going to use this behavior of mutate that was introduced a few versions of dplyr ago, where I can specify a by argument. And this is going to say, group things first, do the mutate, then ungroup it. So I want to group it by day. Now, doing this requires a little bit of care for at least 2 reasons. First of all, I need to go and make sure that I haven't used the day variable anywhere else up here. Like, does it matter that things are grouped by day when I do my temp or my WeatherSit? It ends up not. I haven't referred to the day variable at all elsewhere here. So it ends up being okay. That only affects this last bit. The second thing that I always like to say about the dot by argument in a mutate or summarize is that as handy as it is compared to group by and summarize or group by and mutate in this case, it is less transparent and less explicit. So I encourage you to be judicious in your use of the dot by argument for mutate and summarize and so on. But in this case, I think it's really clever. So let's go ahead and do that. And let's view bikes imputed. And hopefully this is our final product. All right, so going back down to 5 a.m. Here we go. And working day came out to be 0 here. Go a little further down. 1's here. And if there's a place where we're missing many, many more values in a day, it also works out just fine. Incidentally, as I was preparing this vid, I did check my work on this a little bit. I made sure that when I did this mean here, that I never got any decimals, for instance, that something hadn't been coded weird so that, that each working day really was always coded as a 0 or a 1. So I did sort of an idiot check on the people that actually made the data set, it works out okay. Okay, so the last thing I want to do now that I have a bike's imputed data set that is hopefully more complete in some reasonable ways is I would like to rebuild my Poisson regression model using this data set and compare it a little bit to the Poisson model that I built last time using the original bikeshare data set. So how about model old? So this is going to be the model that I built in that Poisson regression video, or at least one very similar to it. I want to model bikers using temp, working day, and weather set. And the data I'm going to use is bikeshare. And the family of my GLM is going to be Poisson. There we go. And I'm just going to, before I even look at this, I'm going to copy and paste it. Because now all I need to change this second time is what data set I'm using. And that's bikes imputed. Okay? And of course I can use the summary command to just print this stuff out. But remember how I loaded up the broom package earlier here? Yeah, so I'm actually going to use a command from there. I want to use the tidy command. And first let's tidy model old. And this just gives us the table with all the information about our coefficients. So the estimates, the standard errors, the p-values, things like that. I noticed I called my new model old as well, so let's change that to model new. And let's get tidy on model new. And we'll just execute both of those. Can I see both of them at once? Yes. Hang on, did I really run both of these? Bikeshare, bikes imputed. There we go. Okay, great. So they are similar, but they're not identical. In particular, our old model has an intercept of 3.89 and a slope of 2.13. For the new model, the intercept is a little bit less and the slope is a little bit more. Now, I say intercept and slope, but of course, we're talking about Poisson regression here. These aren't literally intercepts and slopes. These are going to be intercepts and slopes on a transformed scale using that link function for the Poisson regression model. What this does mean, however, is that our new model here can be gotten by shifting the previous one down a little bit, which I guess makes sense given that we've introduced some zeros into our data set. But we should expect to be having greater rates of increase as we read from left to right. So the model is going to be similar, but not identical. Let's look at one test value for comparison. So what I'm thinking here is I'm going to make a new data set using a data frame. I could use Tibble, but whatever. And I just want to have a new observation. Let's have a temp that is the average temperature, 0.5, or at least the median temperature. We want working day in here. And let's make it a 0. Let's not have it be a working day. And let's have weather sit be clear. I'm just choosing those other two, these last two more or less at random. And then let's get some predictions from our models, from each of our models for such a day, for a clear, non-working day with average temperature or median temperature. So predict model old on new data. And I want type equals response. I would like to actually have number of bikes come out, not have something on that other scale. All right, so the old model predicted that on a median temperature day, not working, clear weather, that would be 141.1 bike rentals on average. What about the new model? The new model predicts the number of bike rentals would be 140.2 0.4. So it decreased by what? About 0.6 bike rentals. Is that a huge difference? Well, I guess it depends on your perspective. If you're thinking about percentage change, possibly not that much. Is this a substantial improvement in your model? I probably want this model rather than the previous one. So potentially this is a beneficial thing. Now, obviously, there's a lot more that we could do to make this model better, to think about how to improve this data set that I'm not going to get into in this video. The one other thing that I did mention in that Poisson regression model video that I'm not getting to today is that weather sit has 4 levels as it's coded in here. There's clear, cloudy, light rain, and heavy rain, or light rain, snow, heavy rain, snow. But there's only one actual observation where heavy rain, snow is listed here. So if this video wasn't already pretty long, I think I would want to go back and recode that. So that's a challenge for you. All right. Bye, everybody.